This is my kinematics reassessment. The question is kind of long, so I'll just read the parts what I need to figure out. The range of a projectile. Derive an equation for the range in terms of initial velocity, gravity, and the angle of elevation. So we start out with this equation, plug in what we know. Our vi sine theta is the y component of the initial velocity. So we plug it in, and this is what we get because we moved this, we multiplied out, and because this negative g, negative plus times positive is equal to a negative, so we move that to the other side. And then because of this delta t here, we divide by delta t, and that cancels out the delta t, and then we're left with a delta t here, and then that is equal to vi sine theta. And so we solve for the delta t by multiplying by g divided by 2, and we're given 2 vi sine theta over g is equal to delta t. Now the range is equal to the initial velocity of the initial x component of the velocity times delta t. Because our delta t is this, we plug that in here, and our initial x component of the velocity is this, we plug that in here. Multiply that out, we're given 2 vi squared sine theta cosine theta divided by g, and that is equal to our range. Now to find the range, we plug in our initial velocity was 50 meters per second, 50 meters. Our angle of elevation was 30, so we plug in sine 30 cosine 30. Our gravity was 9.8 meters per second squared, and when you multiply all that out, you're given 221 meters as your range. This is the picture that I drew for the problem. Ignore that I kind of messed up there. So now that we have the range, the next part, or that this was part A, that was part B, find the range. And then if the cannonball travels far enough to hit the wall, find the height at which it strikes. So we have everything we need except for the time. So we come over here, plug in what we know, or we take this equation and we solve for change in time. And once we have that, we plug in our knowns, and we're given 4.96 seconds is the change in time. Now we come back over to our original equation that we used up here, and we plug in the initial velocity, 50 meters per second, in the y component, which is sine 30 times 4.96 seconds, plus 1/2 negative 9.8, which is gravity, times 4.96 seconds squared. You multiply all that out, you're given 125 meters minus 120.55 meters, and you end up with y is equal to 4.4 meters, or 4 meters.